All right, so starting with box number 5, we are going to figure out how to choose the correct trig ratio and solve for an unknown. So the first step in box number 5, it says to identify the reference angle. So in a given problem, they will give you a reference angle, right? And then after that, you are going to figure out which sides are you using with that reference angle. Are you using the opposite, the adjacent, or the hypotenuse? Which combination are you using? And then based on that information, you can figure out which trig ratio uses those sides. Is it sine, cosine, or tangent? Remember the SOHCAHTOA. Okay, I'll just write that out here for you guys to see. Sine is the SO. Remember, so opposites and hypotenuse, that's what the O and the H stand for. Cosine is the CA, so the adjacent and the hypotenuse, that's what the A and the H stand for. And then for tangent, T for TOA, opposite and adjacent. So depending on if you're using the opposite, adjacent, or hypotenuse, you will choose sine, cosine, or tangent based on SOHCAHTOA. And then after that, you write an equation using the trig ratio and the known values and x. Then you can solve the equation. So then here on the box number 6 is an example. So let me just zoom out. So if we give you this problem with this triangle, and we say, okay, this is 36 degrees, and there's the x on the opposite side, and the hypotenuse is 20. And then, oops, oh, I can't see. Give me a second. Okay, if we give you this problem, you first identify the reference angle, and you can see that based on the fact that they gave you 36 degrees over here, that will be your reference angle. So the reference angle is 36 degrees because it is the angle given to you. Next, which sides are you using with that reference angle? So based on that 36 degrees, we are using the opposite side, right? That's over here with the x, and we are using the hypotenuse. So if we're using opposite and hypotenuse, which trig ratio uses those sides? Remember in SOHCAHTOA, the opposite and the hypotenuse are part of the so it's the sine that we're using. Sine uses opposite and hypotenuse. SOH stands for sine, opposite, hypotenuse. So we're using the sine. And then we're going to write an equation over here in step 4. We're writing an equation using the trig ratios and the known values in x. So sine of something is equal to opposite over hypotenuse. I'm just going to put the angle here. Sine of the angle is equal to opposite over the hypotenuse. And so the angle was 36 degrees, so that's where we put our 36 degrees. The opposite side was x, and the hypotenuse was 20, so we fill it in. Let me just highlight where everything came from. So the 36 degrees was our angle, the reference angle. The opposite side was literally the side opposite of your reference angle, so it's the x in this case. And then the hypotenuse was 20 because it's the longest side of the right triangle. So this is the hypotenuse. So you fill it in. Sine of 36 degrees is equal to x over 20. And then, yes, sorry.
It's okay. What do the circles say inside the circles?
Oh, opposite and hypotenuse. I was trying to write it, but then like it's kind of small, I know. I was trying to fit it in the circles. It just says opposite and hypotenuse because that's what sine is. So sine is the SOH part of SOHCAHTOA, and the O stands for opposite. So that says opposite. And then the H stands for hypotenuse, so that says hypotenuse.
Okay. Thank you.
You're welcome. Sorry, I wrote it really tiny because I was trying to fit it in there. So opposite over hypotenuse.
What's in the purple circle, like the one next to sin?
Oh, okay. So that is theta. It just looks like an egg with a ribbon across it. It just represents angles.
Okay, thank you.
Yeah, it's just a Greek letter. I forgot if we used it in this class before, but it just means angle. So the angle, sine of the angle is equal to opposite over hypotenuse. So sine of 36 degrees is equal to x over 20. And then we're going to solve for x. So since x is being divided by 20, you can solve for it by multiplying by 20 on both sides, in which case you get 20 sine 36 degrees is equal to x. And then you plug that into a calculator, and then they'll tell you 11.76. And remember, we're just using this on like Delta Math calculator. Okay? Any questions on that example, that lengthy example? Okay. If you do, just interrupt me. I will always go back for you. Don't worry about that. Let's scroll to the next box, which is we're going to do 8, 9, 12, 13, and 16, 17. Why are those numbers so weird? It's because we already did boxes. We already did this, this, and this box. So now we're doing like these, okay? Okay, so let's start with box number 8. To solve for a use to solve for a side x in the numerator. So it's kind of like the example we just did. So if you have the reference angle over here, and we are using the opposite side and the hypotenuse, then we want to be using sine. So we put sine of 25 degrees is equal to the opposite over the hypotenuse. So you can see it's already plugged in. Sine of 25 is equal to x, which is the opposite, over 16, the hypotenuse. And then you solve for x by multiplying by 16 on both sides. Okay. So that was just like the example we did earlier. Then you could also have x in the denominator. It can be in the bottom. So let's say in box number 9, if you're looking at box number 9, let me zoom in a little bit actually. If you're looking at box number 9, here's your reference angle, and we're using the opposite and the hypotenuse. So we're still using sine, because sine is the opposite over the hypotenuse. You write sine of 64 degrees is the opposite, 22, over the hypotenuse x. And since x is in the denominator, what you can actually do is switch the x and the 64, or sine of 64. So now instead of sine of 64 is equal to 22 over x, it's x is equal to 22 over sine of 64. So literally the bottom switches with the other side. Okay, so that is the process we can use for that. And then you can just type 22 divided by sine of 64 into your calculator to get the x all by itself. Are there any questions on that one? I have a question just in case you guys were too shy to ask or whatever. If you're wondering why you can just switch these two, the sine of 64 and the x, like why can you switch the denominator with the other side? Think of it in terms of numbers. So like let's say we have 5 is equal to 20 divided by 4. Right, 20 divided by 4 is 5. You can check that on a calculator. So you can switch the 5 and the 4, just like you can switch the x and the sine of 64 in this example. You can switch them the same way because 4 is equal to 20 divided by 5. So you see when I switch it, it's still a true statement. So that's why you can switch it over here as well. Even though we're dealing with sine of 64 and x, so many letters, and you might be confused why, hopefully you can remember this thing and see that with numbers, you can switch the denominator with the other side and you can still get the true statement. See, the 5 and the 4 can switch, just like the x and the sine 64 can switch. Okay. No one asked that question, but I thought I would answer it anyways. Let's go on to the cosines. So cosines is box number 12, so we're now dealing with this box. So direct your attention over there. And so let's take a look at what happens when you are given this reference angle. Now we are dealing with the adjacent side, which is touching the angle itself. So that's the x over here. And we're also still dealing with the hypotenuse. And so cosine is equal to the adjacent over the hypotenuse. And so that means cosine of 51 degrees is equal to x over 20. Then you may multiply by 20 on both sides to get x, type it on a calculator, and you'll get your answer. Any questions on that one? Okay, Box number 13 then, it's the similar situation except that this time your x is going to be in the denominator. Let's take a look at what happens. Here's your reference angle. It's the only angle they gave you, so it's the reference angle. You have your adjacent side right over here and the hypotenuse, which is directly across from the right angle always. So we have adjacent and hypotenuse. That means we're dealing with cosine because cosine is adjacent over hypotenuse. So we put it together. Cosine of 48 degrees is adjacent over hypotenuse. And then that is 48. Cosine of 48 is 22 over x. Once again, we can switch the x and the cosine 48. So now x is equal to 22 over cosine 48. Then you type it in on the calculator and you get your final answer. Any questions on those two boxes? Okay, let's go down to boxes 16 and 17. So now we're dealing with the tangents. Remember, the tangents are opposites over adjacent based on SOHCAHTOA because TOA in TOA stands for tangent, opposite, adjacent. So tangent is opposite over adjacent. Let's take a look at how that plays out in box number 16, where we are given that as our reference angle. So then we are dealing with the opposite side and the adjacent side. So since we have opposite and adjacent, we should put it with a tangent. So tangent is opposite and over adjacent. So then we put it together. Tangent of 23 degrees is x over 12. Multiply by 12 on both sides. Type it in a calculator and you get your answer. 5.09 is equal to x. Then for box number 17, we are given our reference angle here. That's the opposite side. This is an adjacent side. Okay, so we choose tangent because tangent is opposite over adjacent. Put it together, we get tangent of 31 degrees is equal to 6 divided by x. Remember, when your x is in the denominator, you can switch it with the other side. That's what we do over here. X is equal to 6 over tangent 31 degrees. We type it in the calculator and we get our answer, 9.99. Are there any questions? Okay, doesn't sound like it. So I'm going to stop the recording and then we'll do some delta math examples.